dear student. I hope you are doing well. I am Madam Gracious Kanziani from Educare Tanzania. We are proceeding with our chemistry series session, and my student, we are proceeding with our amazing topic, which is ionic theory and electrolysis. And in this topic, we have already covered the concept of ionic theory. We have already covered the concept of electrolysis. I hope you enjoyed the session, and now keep following. We are proceeding with another subtopic, which is all about the laws of electrolysis. In these laws of electrolysis, my students, we are going to see the different ideas proposed by scientists concerning the electrolysis. Here, there is a direct relationship between the amounts of the product formed at the electrode and the quantity of electricity that is passed through the electrolyte. Kwamba katika hizi law of electrolysis tunaangalia ule uhusiano uliopo baina ya ile electric current, the quantity, we're going to see the relationship between the amount of product formed at the electrode and the quantity. Kwa hiyo tunaenda kuona the amount of the product formed. Vile vile tunaenda kuangalia the quantity, ambayo quantity tunaenda kuangalia that's current, the way they pass through, in which quantity, plus the amount formed, the mass there. So we are going to see this relationship, and this quantitative aspect of electrolysis was first investigated by the Michael Faraday and is summarized into two laws known as Faraday's law of electrolysis. Kwamba huu uchunguzi wa hiki kiwango au kiasi, the quantity. When we talk about quantitative, we are talking about the quantity, kiasi fulani. So hiki kiasi ambayo tunaangalia ile quantity au ile amount iliyopo, uhusiano wa amount na quantity ambayo ni ya ile electricity ambayo imekuwa used in the electrolysis mechanism or reaction. Now ilikuja kuwa investigated, ilifanywa uchunguzi na huyu mwana science ambayo ni Michael Faraday, na akaja na idea akaisummarize kwa kupropose the laws of electrolysis, ambayo alikuja na two laws of electrolysis ambazo zilikuwa named or zilikuwa known as Faraday's laws of electrolysis. So my student, we are going to deal with these laws of electrolysis, whereby we are going to start with the first laws of Faraday electrolysis. But the two laws of electrolysis help to determine the quantity of substance liberated during electrolysis. Kwamba hizi law zilitusaidia au zinatusaidia kujua ni kiwango gani au ni kiasi gani cha umeme ambacho kilikuwa liberated wakati wa electrolysis, ni kiasi gani cha umeme ambacho kimetumika, ni kiasi gani cha umeme ambacho kimetolewa wakati hii electrolysis inaendelea kutake place. Now the law depend on the three factors which are, yani law hii law ya Michael Faraday yenyewe alikuja na idea tatu. The law zake zilidependi kwenye the three factors. The first factor is time, kwamba there is a time during the production of electrolysis, during the way electrolysis tend to be produced, or the way those reactions take place, so as they can drive the non-spontaneous reaction. So there is a time, but also the magnitude of the current supplied. So kuna kiwango cha umeme, magnitude. When we are talking about magnitude of current, is another factor of this concept of the law of Faraday. Now another is charge on the ion of the element, kwamba charge ya zile element. We have seen the dissociation of ions. We have seen the interchange of the univalency, monovalent, bivalent and so forth. Na tuliona katika sessions zilizopita. So you can see this scientists investigate and come up with the three factors whereby can it describe the relationship which are there between the amount of the product formed during the electrolysis, also the quantity of the electric charge produced or liberated during the electrolysis. Now let us start with the Faraday first law of motion, or Faraday first law of electrolysis. Now, Faraday first law of electrolysis relates the mass of substance liberated and the quantity of electricity used to liberate it, kwamba yenyewe inahusisha masi ya quantity au masi ya substance na mass ya substance liberated, mass ya substance ambayo imekuwa liberated, vile vile na quantity of electricity ambayo imekuwa liberated, kiwango cha electricity ambacho kimekuwa liberated. So this is how the first law came with this idea. Now the law states that the mass of a substance liberated at or dissolved from an electrolyte electrode during electrolysis is direct proportion to the quantity of electricity passed through the electrolyte, kwamba kiwango cha masi ambacho kimekuwa liberated na ni direct proportional na quantity ya electricity ambayo imekuwa produced wakati wa electrolysis. So we can see the relationship between the mass and the quantity of electricity is directly proportional. This is according to the first laws of Faraday first law of electricity. In alternative way, you can state this law as follow, that this law stated the mass of a substance produced or dissolved at an electrode during electrolysis is directly proportional to the mole of electrons transferred at that electrode. Kwamba tuliona kwamba there is some amount of those electrodes, some amount of copper electrodes, copper metals, they tend to dissolve, to be deposited. The mass of cathode tend to increase due to deposition of cathode, due to deposition of copper electrodes. So we are going to see that this substance liberated or dissolved during electrolysis inaenda kuwa proportional, direct proportion to the moles of electron ambazo ziko transferred at the electrode. Ina maana when we talk about proportional, direct proportion means that if the one increase, also the one increase too. If the compound decrease, also the another will decrease. That is the relationship between proportion, direct proportion. Now, the law is used to calculate the masses of metals such as copper deposited at the cathode by working out the change in mass at the cathode, kwamba hii law ilitumika kufind those masses ambazo zimekuwa deposited at the cathode. Tuliona katika zile selective electrolyte ambayo tuliona kwenye electrolysis of copper sulfate with copper electrode. Tuliona kwamba ile copper ilikuwa the copper which was in iron, in iron form, discharged into solid, but also those, that solid copper tend to dissolve again. So at the same time there is accumulation or deposition of copper at the cathode, kwa sababu ile copper at the cathode ilikuwa converted again into the iron na ikatokea deposition at the cathode. So this law can help us to find or to identify or to calculate the masses of metals such as copper deposited during the cathode by working out of the change in the mass of the cathode. For example, if the initial mass of copper is 63,680 gram and the final mass is 33,705 gram. Now the mass of copper deposited is equal to take the 63.705 minus 63.685, means that the mass deposited is equal to take the final mass minus initial. Unachukua ile mass ambayo imekuja kudeposit pale, unatoa na ile mass ambayo ilikuwepo. So you can see that you are going to have the difference of masses, the mass before deposited and after deposited. Kwa hiyo tutakuja kuona kwamba tunachukua ile final minus initial, then tunapata amount, au tunaweza kuidentify the amount of copper deposited at the cathode. Now something to note is the quantity of electricity is measured in coulombs, kwamba quantity of electricity tunaiongelea hapa ambayo ndio ile the quantity ambayo ndio quantity that is produced during the electrolysis, it is measured in coulombs. Kwa hiyo ile current the quantity of electricity inakuwa measured in coulombs. So these coulombs can be used at the SI unit. And 1 coulombs in the quantity of electricity charge that passes through a given point in a circuit when a current of 1 ampere flow for 1 second. Kwamba kumbe when we talk about coulombs zenyewe the 1 coulombs is the quantity of electric charge. Kwa hiyo tunaongelea ile electric charge ndio inaenda kurepresent 1 coulombs, ambayo electric charge ina pass through a given point of in a circuit when a current of 1 ampere flow in a 1 second. So the current is measured in the ampere, which is denoted by capital letter A, and the time is measured in second, which is denoted by small letter s. Now here is the simple result for the verification of the Faraday first law of electrolysis. So you can see here you have a current, you are given your current which is made up of ampere, and the unit is represented by capital letter A. Here we have a time, but we have a quantity of electricity which is made up of coulombs. Also we have the charge in mass, kwamba hizi ni change in mass, kwamba ndo ile mass liberated, the amount liberated. Now as you can see here you have 0.26 7, another current una 0.567, 0.783, 1.067, 1.317, 1.067, but the time we have it is constant from 0.267 up to 1.317, ni 300 yote ipo constant time. But ukija kwenye quantity of electricity ipo 80, 170, 235, 320, 395. And when you come in change in mass, they tend also to vary. We have 0.025, 0.049, 0.074, 0.099, and so forth. Now, how can we prove the relationship or the law of the first Faradays, which show that the mass liberated is directly proportional to the quantity of the electric produced? Now, here, when a current of 0.267 ampere is passed for 300 seconds, the quantity of electric charge which is Q that passes is calculated from, kwamba ili kuweza sasa kutafuta ile the quantity of electric passed through or passes through during the electrolysis process or mechanism. Now we have to use this question that Q which is the quantity of charge is equal to IT, whereby I is current ambayo inakuwa represented by ampere, capital letter A, and T is our time which is represented by second, small letter s. Now in order to have Q, you are going to times to multiply 0.267 ampere times 300 second. So you are going to have the quantity the quantity of electricity passes during the electrolysis. Now here is the SI unit which is coulombs, or you can write ampere s, ampere second, or you can write coulombs is okay. Hapa tunazingatia vizio, so kizio cha electric quantity ni coulombs, or unaweza ukaandika this one ampere na second. Ampere ikistand for the for electric current, alafu S ikistand for the time which is the second. Now when the quantity of electricity passed is doubled, the amount of copper deposited almost doubled. What does it mean? Kwamba kumbe the quantity ikiwa doubled means that the mass of copper will be deposited itakuwa pia doubled, kwa sababu tumeona kwamba the mass liberated is direct proportion to the quantity of electric passed through the electrolyte. So kama mass itakuwa deposited kwa kiwango fulani, mean that electric energy or electric quantity itakayokuwa produced au itakayokuwa liberated during the electrolysis, it will be the double the same with the mass of the substance. Now a graph showing the mass of copper deposited against the quantity of electricity passed is a straight line passing through the origin is shown in the figure below. Now this is a graph which shows the representation between the mass of the copper against the quantity of electricity. So you can see our nature of graph. It is passed straight. It is made up of a straight line in nature which is from the origin. What does employ in this graph? Mean that as you increase the mass is where the quantity of electricity also increase, or as we decrease the mass is where the quantity of electricity tend to decrease. So you can see here, once you have 1 point ukiwa na 150 quantity of electricity, hapa una 0.05 mass of copper deposited. But also once you have 0.2 then you are going to have the 600 quantity of electric charge. So the way you increase the quantity of electricity is where the mass liberated at the large amount. So this means that the quantity or the mass is directly proportional to each other. Now if M is the mass of a substance deposited, I is the current of electricity passed, and T is the time in the second. Now Faraday's first law of electrolysis is expressed as follow, kwamba kama mass ni ile amount or the mass of a substance ambayo imekuwa liberated or deposited, vile vile I ni current. We're talking about the current, electric current, but T is all about time. Now the first law of electrolysis, the Faraday first law of electrolysis, itakuwa expressed as mass is direct proportion to IT. But this proportionality symbol we can remove it by replacing with Z. So the mass of the first Faraday law is equal to the this Z, which is the proportionality symbol, and IT. But what does this Z mean? Z means that it is a constant known as electrochemical equivalent. That is what Z represents. But others, M is the mass of the substance produced or consumed in grams, kama tulivyoona kwamba ni ile mass ambayo inakuwa produced or consumed. Vile vile I is the electric current in ampere. Hii tumeiona. So T is the time taken for deposition in second, kwamba muda ambao ulichukua muda ambao ile copper ilitend to deposit, ile deposition ilivyo take place, that time is where we are going to consider in this relation or in this laws of first Faraday's law. Now that's Z is equal to M over IT. Now in the next session we are going to see the more about Z, whereby Z is all about electrochemical equivalent. So we are going to see the different relationship, different reaction, formulas related with the electrochemical equivalent, with the electric current, with the quantity charge, with the mass, even time. And I hope my student, this is short this short concept of first Faraday law, you have mastered it, and I know you will keep watching it so as you can understand as much as possible. Thank you for watching. But before I sum up this concept of first Faraday law, here there is a task for you. Try to attempt it so as you can improve your understanding concerning the session. The question is, what do you understand about the first law of electrolysis? So my student, I know that because umepay attention, umesikiliza, umeelewa, so is where you can able to attempt the question. And though I advise you to go through the books, you will see a lot of concepts, a lot of material there, so as you can broaden your understanding and enhance it effectively. Now, my student, thank you for watching. This marks the end of our session today. Have a nice time. Keep watching EducateZ. Don't forget to subscribe and like and share this video with your friend so as everybody can learn. Bye bye. Have a nice moment.